Hi there. I'd like to introduce myself and also to offer you an apology. My name is Shane Coughlin and I'm one of the founders of the OpenRelief project. We'd hoped to have Carl down to speak with you today and to give you a full introduction of what we're doing and why and how we're doing it. But sadly, he couldn't make it, and I do apologize. I know we advertised this, and it's a real shame. It's a real shame. All I can do in exchange, as part of my apology, is to try to give you a quick overview by video from Japan, letting you know what we're doing and hopefully encouraging you to get in contact with us, and perhaps we can interact, share some technologies, share some knowledge. OpenRelief is a project to create open modular ways to gather data for disaster relief. At the moment we're focusing on two things in our approach. One thing is a way to get an eye in the sky up there for video, photos, and mapping. Another is a way to have sensors on the ground that can read things like, for example, radiation, send that data via the network or up to the surveillance units in the sky. And then we combine the knowledge and we put that into disaster management systems like Sahana Eden. What we have in practice is a prototype, open source, open hardware airframe and computer system to make a robotic aircraft that will allow us to have the eye in the sky. This is a very simple thing on a component level. Nothing in there is revolutionary. It's high-end RC kit for the plane. It's simple computers like Raspberry Pi for the computational analysis. Autopilot, again, it's pretty much standard, off-the-shelf, ArduPilot. We're benefiting from the fact that a lot of work has been done before. All we're doing is combining the technologies to solve our particular problem. Our robot aircraft, therefore, is probably not as exciting as some of the items you might have seen today or will see later. And it's certainly not as exciting or as advanced as some of the research technology we see around the world. This is purposeful. We're not trying to make something new. We're trying to use technology that's available, that's cheap, that's replaceable to solve a problem. So it's not a technology project here at OpenRelief. It's a design project trying to find a way to solve this issue we have with information gathering. The sensor which the plane communicates with, the sensor that we have a demo of now, a radiation sensor which I believe Andrew might have brought with him today, is again a relatively simple approach. The idea here is that we have a nanode, we have an ionization chamber, and we collect data that we can then send to the aircraft or over the network. And it's not a sophisticated sensor. It's a canary. Its purpose is to let you know when something's going awfully wrong, and you know to send people to find out what precisely is going wrong and what we can do about it once we have that data. Simple concepts, simple approaches. We've built a community around this in a rapidly evolving way in a very short space of time. OpenRelief as a project, well, it's only about 4 months old. We already have 2 prototype aircraft. One is in the UK, it's based up in Newcastle. One is now in Japan, it's based here on the island of Shikoku. And we're using these prototype aircraft to try out hardware and try out software to refine the concept of a cheap, simple eye in the sky. We're getting great work from people like Andrew in prototyping technology like the radiation sensor. And we're looking for more people. We had some articles in the Register recently. The Register was very, very useful for us in the UK. It gave us a lot of new subscribers. We've got like 93 people on the dev list now. We're looking for people who know hardware, we're looking for people who know software, we're looking for people who can help us on integration and testing. Quick bird's eye overview of the drone technology, which is probably why you're sitting here listening to me. The drone technology we've got, I said it's off the shelf, it's pretty basic, I'll run you through it. It's an RC168 airframe from Hobby King, which is Hextronic in China. So it's fiberglass, balsa wood, vinyl, it's nothing special, it's a $100 airframe. That airframe is using electronic motors and batteries and so on, all recommended by Hextronic. It's pretty much off the shelf. I mean, it's LiPo battery, it's a normal RC engine, and other components like the servos, well, we're using all metal servos, and they're just off the shelf, nothing special. I think they're 9-gram servos or 12.5. The stuff in the plane, again, it's not revolutionary. The Raspberry Pi computer, well, you know that. No introduction needed there. The ArduPilot autopilot, you're probably familiar with that. In case you're not, it's a very simple Arduino-based autopilot. It's got up to 600 3D waypoints. It's got a black box recording system. You can even reboot it in midair. It's a pretty good piece of kit, and we see it used by people like Tridge down in Australia at the Canberra UAV project, where they're trying to work out how to do bush rescue systems using UAVs. So this type of autopilot, it's not our invention, but we're benefiting from the fact that an enthusiast community is using it, and now people are using it for trying to solve disaster-related issues. So we're working with that community now. We have, as well in the plane, a camera, and the camera is astonishingly simple. It's just a Sony Super HAD camera. It's a 170-degree lens, and it's a fisheye, which originally was intended for being used in a door. So it's one of those doorway entrance security systems. We bought the camera unit from China. It was like $40. All the components in the plane are as cheap as possible, as off-the-shelf as possible, and as disposable as possible. Where we can, we'd love to use open hardware. We always try to use open source. We want to make sure that this can be a replicated technology and can be an improved technology over time. And that's where we're going next. The airframe itself, I said it's dead cheap, $100 airframe. It's not bad, but we're trashing the 2 robot planes we've got. We're wrecking them already, and we've barely started. The reason is that we're not dealing with it in a way that's gentle. We're pushing it on the ground. We're rattling it around. We're trying to see how good would this be in the real world. Fact is, our airframe is not good enough for disaster relief. This is a good RC airframe for enthusiasts to play with, but we need something better. And that's where we're doing an exciting project. Maybe this is where you and we can work together. The OpenRelief project is going to be building an open source airframe. We're learning from the FPV-168 airframes from Hextronic. We're learning from our equipment. We're learning from the third parties who jump on board. And we're trying to develop a 2-meter airframe that will be completely open schematics. Everyone can build it. And we've got prototyping arranged up in Newcastle with a fiberglass company that will help us make some of the components. The airframe, the information about the current setup, the access to software, where we've got cool things like OpenCV doing visual recognition, that's all available freely on our project. Go to www.openrelief.org. Get our information, join our dev list. I'll be happy to talk with you personally and bring you on board. Again, I'm really sorry Carl couldn't come down today, show you things in person, talk through details of the build project. But we are here, we really want to engage with you, and I'm delighted to take questions. I'm delighted to talk with you personally. Whatever we can do to work together would be awesome. So www.openrelief.org for the website. And it's Shane, S-H-A-N-E, @openrelief.org to talk with me.